The evolutionary benefits of bioluminescence. Bioluminescence, the ability of certain organisms to produce and emit light, is a remarkable feature found in a wide variety of life forms, from fireflies to deep-sea creatures. This phenomenon has evolved over millions of years, providing numerous benefits to the organisms that possess it. The evolutionary advantages of bioluminescence are as diverse as the species that exhibit it, playing key roles in hunting, defense, communication, and reproduction. Here's a deeper look into how bioluminescence benefits living organisms from an evolutionary perspective. For many organisms, bioluminescence provides an effective means of defense. In the dark depths of the ocean, where sunlight does not penetrate, creatures like squids, jellyfish, and certain species of fish use bioluminescence to avoid predators. These organisms can produce flashes of light to startle or confuse attackers, giving them a brief moment to escape. For example, some species of shrimp and small fish release clouds of glowing chemicals when threatened, creating a burst of light that distracts predators and allows them to flee to safety. Some deep-sea creatures, like the lanternfish, use their light-producing capabilities to blend into the faint light from above, a technique known as counter-illumination. This helps them avoid predators below by matching the overhead light, making them harder to detect. Bioluminescence is also an essential tool for predation in many species. Creatures like the anglerfish have evolved glowing lures to attract prey. The anglerfish's glowing lure hangs in front of its mouth, emitting light that attracts smaller fish and other prey. Once the prey is close enough, the anglerfish snaps its jaws shut, capturing the unsuspecting victim. In addition to attracting prey, bioluminescence can serve as a bait-and-switch tactic. For example, some squid species use bioluminescent signals to confuse potential prey and make it easier to capture them. The glowing light lures the prey into a false sense of security, only to be caught by the predator when it gets too close. Bioluminescence plays a crucial role in the mating rituals of many species, especially in environments where visibility is low, such as in the deep ocean. For example, fireflies are famous for using bioluminescence in their courtship displays. Male fireflies emit specific patterns of light to attract females, with each species having its own unique flash pattern. Females respond to these signals, allowing the males to find them for mating. In the ocean, the glow of bioluminescence can also serve to attract mates. Some species of jellyfish and squid use bioluminescent signals to find and recognize potential mates in the vast dark waters. In some species, the intensity or frequency of the glow can indicate the health or vitality of a potential mate, ensuring successful reproduction. In addition to mating, bioluminescence can be a form of communication within species. Many deep-sea animals use light to signal each other. For example, certain species of squid and fish can produce light to communicate with others in their group, especially when hunting in schools. This bioluminescent communication can help coordinate movements, alert others to danger, or even synchronize behavior for group hunting. For some species, bioluminescence can also be used to establish territory or warn others of danger. The light signals may serve to indicate that the creature is ready to defend its territory or is unapproachable. The ability to produce light is an adaptation to the extreme and often hostile environments that certain organisms inhabit. Many bioluminescent creatures are found in the deep ocean, where food sources are scarce and the pressure, temperature, and lack of light make survival difficult. Bioluminescence helps them adapt to these conditions by allowing them to attract prey, communicate, and avoid predators in an environment where traditional senses like sight and sound are less effective. In these extreme environments, bioluminescence also serves as a tool for maintaining a balance in the ecosystem. It helps sustain the food chain by attracting and catching prey in a place where other animals might struggle to find food. But no two individuals are the same as ever, already touching on that which is the common example of a better word. An interesting aspect of bioluminescence is its energy efficiency. Unlike traditional light sources, which produce both light and heat, wasting energy as heat, bioluminescent organisms produce light without generating heat, a phenomenon known as cold light. This process is highly efficient, meaning that the organism uses very little energy to produce light. This is particularly advantageous in environments where energy resources are limited, such as the deep sea. Energy efficiency means that bioluminescence can continue to function without draining the organism's resources, allowing it to use its energy for other essential processes like hunting, moving, or reproducing. The evolutionary benefits of bioluminescence are clear. It allows organisms to survive in challenging environments, hunt and avoid predators, attract mates, communicate, and even establish territory. Over millions of years, natural selection has fine-tuned this extraordinary ability to help organisms thrive in conditions where other survival strategies might not work. Bioluminescence is a fascinating example of evolution at work. Pan-adaptation that has enabled countless species to not only survive, but to flourish in some of the most extreme and inaccessible places on Earth.